Now, I want to spend some time with you going over Figure 1-5 in your textbook. That is on page 9, and its title is Earth's Climate System and Interactions of its Components. Now, there's a lot going on here in this figure, and believe it or not, the processes and interactions are highly simplified, right? Because it's just trying to show you how these climate models work. So thinking back to our definition of systems and thinking about Earth as a system, let's look down here where it says climate system, right here. Now, this is showing the different components of Earth's climate system and its interactions. And what you'll notice here is we have the atmosphere, as we talked about, being one of Earth's 4 spheres. We have vegetation, which is part of the biosphere. We have the land surface, which is part of the lithosphere. And we have the ocean, and we have ice, which is part of the hydrosphere. Now, we have this split up into these 5 different components. And on the left over here, we have forcings or causes. These are external forcings that impact the climate system and how they interact. So these are natural forcings, and those include changes in plate tectonics, changes in Earth's orbit, which we'll talk about in more detail later, and changes in Earth's sun strength, because the sun goes through what is called the solar cycle. So actually the strength of the energy coming out of the sun does change a little bit in time, and that goes through cycles. So those 3 things are natural forcings on the climate system. And the variations that you see here on the right are the responses to the climate system. So these forces influence the climate system, which cause maybe changes in the atmosphere, changes in ice, changes in vegetation, changes in the ocean, and changes in the land surface. And because you're changing these different components, it also alters how they interact, which overall influences and impacts climate. Now, above in this diagram, they're showing you some of these interactions are represented. So we have input from the sun. That is solar radiation. So that's coming down to Earth, right? Heating it up. We have sea ice down here, which has a high reflectivity or albedo. So that means that some of this energy from the sun is hitting the ice and bouncing, right? It's not getting absorbed by the Earth. It's bouncing off, all right? And then some of it is absorbed by water, right? And so we have a cycling of water here. We have warm water coming up here because this is a hot spot, and warm water is less dense than cold water, so it rises. We get an upwelling. Cold water sinks, right? So we have some convection going on right here. So this is called convection, which I know you can't really see right there. Let me write it down here. Convection. And that is one of the 3 energy transfer mechanisms. Another one is radiation. So that's how energy from the sun reaches Earth, right? It's the only form of energy transfer that can take place in a vacuum. It does not need a medium to propagate or travel through here. So then we also have carbon dioxide, which is a greenhouse gas, which comes out of these hot spots. It also is emitted from volcanoes, right? And that goes into the atmosphere. And like I said before, carbon dioxide is a greenhouse gas, which means that it's capable of absorbing that long wave radiation that's emitted from Earth because it has a temperature. So it absorbs it and it re-emits it back down to Earth's surface. So that causes a warming effect. Here we have sulfur dioxide, which comes out of volcanoes as well. That is an air pollutant. It's really harmful for us to breathe in, and we'll be going through these different components in more detail next week. We have precipitation, so we have rain, right? And so this could perhaps cause a cooling effect. So we have the back radiation, so we have radiation coming off Earth's surface. We have water evaporating, all right? And we have some greenhouse gases in the atmosphere. Carbon dioxide, methane, and water vapor are all greenhouse gases. So take some time and try to look at the different interactions in this image and imagine, like, how would changing one of these components impact the others? So for example, if this ice sheet expanded, more solar radiation would be reflected from Earth's surface compared to absorbed, and so that would cause a cooling effect.